Fourier transform infrared spectroscopy, or FTIR, is a physical analysis method that uses infrared light in the range of 4,000 to 400 wave numbers. That's 2.5 to 25 micrometers, or mid-infrared, to gain information about the sample composition in terms of the chemical functional groups present, as well as its purity. An IR spectrometer is an instrument that shines infrared light over a range of frequencies on a sample, then measures which exact frequencies are absorbed by the sample. Chemical bonds in a molecule can be viewed as springs connecting two atoms. When the atoms move, these springs vibrate at very specific frequencies that are characteristic of the bonds. A group of atoms in a molecule may have multiple vibrational modes caused by the stretching and bending motions of the group as a whole. If the oscillation leads to a change in the dipole of the molecule, then it can absorb a photon which has the same frequency as that vibration. The vibrational frequencies of most molecules correspond to the frequencies of infrared light. The spectrometer records all the frequencies of absorption in a sample. Our lab FTIR spectrometer can analyze solid, liquid, or gas samples. You can simply place a drop of unknown liquid or a small amount of solid sample on the diamond crystal to collect a sample spectrum. When analyzing the solid sample, it is important to turn the pressure control knob to lower the pressure tower flat tip. Using the software that comes with the IR, a spectrum will be created in seconds. This is what an IR spectrum looks like. Infrared spectra of organic compounds have two general areas. They are the functional group region and the fingerprint region. The fingerprint region contains the lower frequency oscillations, and peaks in this region arise from complex deformation of the molecule, angles bending, or atoms rocking back and forth. They are not representative of any particular functional group, but are very useful when trying to identify unknown samples. If the fingerprint region of your spectrum matches with that of a known sample, that is a strong indicator of what your sample is. The functional group region contains the higher frequency oscillations, or notable bond stretching, and are characteristic of specific kinds of bonds, and is used to identify specific functional groups of the unknown substances. One example might be a peak around 1650, indicating the presence of a carbonyl group.